everyone, we're going to finish up with our nervous system chapter by talking about the final thing in our peripheral nervous system, and that is going to be the function of our autonomic subdivisions. So we learned that the autonomic nervous system, which is our system that controls things automatically, or also known as our involuntary nervous system, can be divided into your sympathetic division and your parasympathetic division. We talked about the anatomy of those two divisions in the last lesson, but let's talk about the function in this lesson. So, body organs served by our ANS receive fibers from both divisions. There are a few exceptions. Some exceptions include blood vessels, structures in our skin, such as that's going to include things like your sweat glands and even your erector pili muscle, and your adrenal medulla only receive sympathetic fibers. They do not receive your parasympathetic fibers. So let's go in and talk about why these divisions are able to function the way they do. Now, both divisions generally serve the same organ, except for those exceptions we listed on the last slide, but they cause antagonistic effects, which means that they affect each other on opposite ends. And the reason they do this is because of the neurotransmitters that they release. One thing I do want to bring up is that their pre-ganglionic neurotransmitters and their post-ganglionic neurotransmitters are different. So please make sure you pay attention to when I use the word post versus pre. We're going to focus on your parasympathetic first. Your parasympathetic post-ganglionic fibers release acetylcholine. Post means that it comes the second neuron. Sometimes these are going to be called cholinergic or cholinergic fibers because they're releasing that acetylcholine. So here you get the co, and then here's the choline there. If I look at this slide and look at our parasympathetic division, which is down here, notice that here I'm focusing on our postganglionic, so that's our second one. And if I go to the end of it, we can see that yes, it's releasing acetylcholine. On the other hand, our sympathetic post-ganglionic neuron, so post again means two, releases norepinephrine or epinephrine. These are sometimes called adrenergic or adrenergic fibers because of them releasing this norepinephrine. The way I always remember that is epinephrine is put into an EpiPen. You're basically shooting your body full of adrenaline. So adrenaline. If I look at this picture, here's my sympathetic division over here, and if I'm looking at my post-ganglionic neuron, so here's my post. If I follow it, my neurotransmitter is norepinephrine. One thing to note, though, is that both of these are talking about the post-ganglionic neurons releasing their neurotransmitters, but it never talked about our pre-ganglionic. Our preganglionic axon for both divisions actually release the same hormone, and that's acetylcholine. So if you look back at that picture, our preganglionic is our first one. So here's our pre, it's releasing acetylcholine. Here's our first one, it's releasing acetylcholine. Here's our first one, it's still releasing acetylcholine. Now that we go into a little more functioning of it, based on what we know, what they release, norepinephrine is going to basically throw adrenaline into our system or into our body. It's going to cause us to have a fight or flight response. So this is going to be called the fight or flight division. It is responsible for whenever we are emotionally or physically stressed or threatened. So this occurs whenever you're embarrassed, whenever you exercise, whenever you need to run away from danger, or even just when you're overall stressed because you're tired from your day. What happens is when you are stressed, anxious, exercising, you tend to have the following characteristics. You tend to have a very pounding heart because your heartbeat's going to increase. You have rapid, deep breathing because you need to get oxygen to your lungs. You have cold, sweaty skin. You have sweaty skin to release temperature. And your pupils are going to dilate in order to let more light into the room. Now, oftentimes people ask me, why is my skin cold when I'm sweating or when I'm working out? All that means is that the blood that's usually near your skin actually is diverted and it goes to your skeletal muscles that are working. So, since it draws your blood away from the surface, your skin feels colder. And that's just because they're trying to put blood to the areas that need it. Oftentimes, your autonomic division is called your E division because of the function exercise, excitement, emergency, and embarrassment help you kind of remember what it does. Now, the effects of our sympathetic nervous system, since you're getting pumped full of adrenaline and you're getting hyped up and worked up, can continue for several minutes until those hormones are destroyed by the liver. So while the nerve impulse is very brief, you can get anxious all of a sudden, or you can take off running real fast. The hormonal effects may linger, which explains why you need time to calm down if you have, let's say, a panic attack, or you're very anxious about something, or maybe you're embarrassed. Maybe you've just got done running and you need time to just catch your breath and cool down. All of these are because our sympathetic is fast but can often linger. Why do we have our sympathetic division then? Well, the reason is because it allows our body to cope with situations that may threaten our homeostasis. If our life's in danger, we want to be able to run away from it. If for some reason we are going into a situation we don't feel comfortable about, our body's going to tell us. The opposite end of the spectrum is parasympathetic. This is not going to be your fight or flight. This is more housekeeping activities. So, what occurs in your body whenever you're resting on the couch, whenever you are having a good time and digesting your food? This is usually the time in which your body starts to conserve energy for when it does need it for your sympathetic division to use. Some daily functions that you're going to notice is generally when you're relaxed and calm, your blood pressure decreases or it's not as high. You tend to have a lower heart and respiratory rate because you don't need as much oxygen in your body. Digestion also increases. All that food that you ate has to be broken down in order for your body to use it. So it starts breaking down some of your food into macromolecules that your body can use for energy. Your skin becomes warm because blood doesn't have to be diverted to your heart and your skeletal muscles. Blood can flow through the veins and arteries and capillaries near your skin. This is sometimes called your D division based on a lot of the functions start with the letter D, such as digestion, defecation, and diuresis. And defecation and diuresis is just eliminating your feces, or other words, your poop, and your urine or your pee from your body. We end this lesson by showing you this table. This table can be found in your online textbook, but I've also uploaded it onto my website for you guys to use if you need to. I know a couple of my homework questions do come from here. This shows us our target organ or system being affected, and then what effect does our parasympathetic division versus our sympathetic division have on that system. A good example of this is your digestive system. Whenever we are in our resting and digesting phase, our ability to secrete enzymes to break down food increases. But with our sympathetic, it's actually going to decrease because we want to use our energy elsewhere. If we talk about our lungs, our parasympathetic is going to constrict our bronchioles, or basically our airways. We don't need as much air or oxygen, so we don't have to have these be as big. Whereas if we are in our fight or flight response, We want those bronchioles to dilate in order to get more oxygen into our lungs. You can go down each one of these and look at the organs and then see how these systems affect them. And you're going to notice often when you are very anxious or you're exercising, how do you notice any of these effects? Here's the other slide, and I've also uploaded this one as well in the same document. Again, these are all in your textbook, but let me know if you have any questions over any of them, and I'll be more than happy to help. Otherwise, that finishes out our nervous system. Make sure that you're asking questions, you're coming to see me, and I hope you guys have a good day.